Hi guys. Uh, Today we also learn about the synchronous motor big curve. We will compare and the synchronous generator curve. It looks like both of them V. But we have kind of confused how we interpret them. You know what I mean? So let's see. First picture is a generator. Uh, Here, generator, and this is a motor. So first of all, we need to think first. Generate is generally we supply, right? Supply energy, right? And motor is the consume the energy, right? So yeah, this is important, the basic concept. You know what I mean? So our power system here, sender. This is generator. This is sending, right? And VR receiving part. There's many motors, right? And so this is receiving part. Even though the current is going through from here to here, Vs to the VR, but this is sending. This is receiving part. Different, totally reverse way of concept. One part is sending, one part is receiving. Receiving means spending, right? Consumption. So look at that. So we could make it the voltage equation E equal to this. And for example, here, current way is consumption, right? And this is sending. This is consumption, right? So we could, yeah, make a V voltage equation like this, depending on the sending and then consumption. You know what I mean? So different concepts. So let's see next picture. So this is yeah, I'll show you guys. Yeah, this is when the over exciting. You know what I mean? This is a generator. This is motor. I'll show you. First of all, here the yellow line is P. You know what I mean? The P is same values. We just want to see the what's going on the current. You know what I mean? So Q part, we want to see it. So first of all, look at that. This is power factors when was first well one power factor is one. This red blue black line. Sorry guys. So look at that. The standard is uh, V. So V is zero, right? And then we make it. This is E. But what I mean is we wanna overexciting means we uh, increase the IF, right? IF means E is increased. If you guys are kind of confused this lecture, which means you guys didn't understand the previous lecture, okay? I hope so you guys understand. So which means now overexciting means E is increasing. So we look at this point to V is increasing E, right? This point, I will say E1 point with the letter. So look at that. So V is the same, right? So if we add it here, yeah. So now we make it this new page, right? So if we see we want to find out I, right? The first time I was here, but look at that. If we overexciting, what happened at the current? So J means 9 degrees. We see it, right? So, yeah. So current is what happened? So current is what happened here? 9 degrees. It's a lagging, right? Compare, right? So this is motor. What happened? Look at that. So if we increase E, what happened? E is this point, right? So we need to here. So 90 degrees. You see it, right? Yeah. Yeah. Okay. Not that 90. I like it. Yeah. So current is now. What happened? In the same overexciting situation, the general part is the current is lagging. And here, motor is leading. That's weird, right? But as I said, this is the concept. One part is sending the reactive power, and one part is receiving and consumption the reactive power, right? So yeah, let's see more. So next picture is under exciting. What happened? Let's see. I will see this. So this is G, right? So if we under, which means E is come down, right? So if we add E to here, no, reduce here, what happened? So here is I, J, X, S, right? So 90 degrees. So which means now under exciting current situation, under exciting situation, the G part, the generator part, sorry, is leading. And what happened here? E is reduced. So if we reduce to here, what happened? Here is I, J, X, right? So 90 degrees. Here, this is when under exciting situation, the current and motor part is lagging. You know what I mean? So just sorry, I'm kind of yeah, to say it kind of loud. So the result is, you know what I mean? Just the concept is this is actually a V curve depending on the motor and the generator, right? But as you can see here, over exciting here and here, we say generator part overexciting lagging current, right? But here overexciting this part motor is leading the reverse. You know what I mean? It totally reverse. But as you guys can see here, the current is generator part is just sending. So that's why, yeah, actually it's the same. But what I mean is we are sending here Vs to here's I, right? So we are sending this concept G is, and motor is we are consuming, right? Motor is consuming. Current weight is the same, but what I mean is receiving. You know what I mean? Receiving. So totally different concept. You know what I mean? So that's why you guys kind of compares what is the leading current and what is the lagging current, like when you interpret the big curve. You know what I mean? Motor and generator. So lastly, I wanna emphasize is this one. If we add the capacitor bank, capacitor, for example, this is power system line. If we add the capacitor C, capacitor bank, and this is BI, and for example, this is there's motor. Capacitor bank, when the current is coming to here, we say C is spending the leading current, right? But once the C is working as a generator, you know what I mean, sending to here, the reactive power, it's a sending, this is consuming, and this is sending the leading current, lagging, you know what I mean? So if you guys understand the sending and the receiving, receiving means consuming. So you don't need to confusing about this. Yeah, that's your today's lecture. Thanks, guys.